Hello, ladies and gentlemen. My name is Vasco A. Corner. Today I'm here to bring you a new edition of the Ankless Success Tutorial. And today I will look at specifically, I will look at the EKG, a very hot topic in the Ankless. And most of our friends find it difficult to master the EKG. Today I will bring you a very easy method how to master the EKG, and when you go through this you should not have any problem with the EKG at the anklet. Let's begin. Before starting the EKG, there are a few things I want us to go over that will make it easier to understand the EKG. Now, I'm going to draw a picture of the heart here, and I want us to understand this picture well. It is the beginning to understanding the EKG. Now, there are things I want to point out here. When you hear lob dub of the heart, lob dub of the heart, it's the same as cardiac contraction and cardiac relaxation. It's the same. It's the same as systole and diastole. Now, so all of this here simply means our heart has completed one cardiac cycle. One cardiac cycle. One cardiac cycle has been completed when we have when we have a lob dub, meaning the heart has contracted and has relaxed, and there has been completion of one cardiac cycle. When you hear lob is systolic, dub is diastolic. So lob dub meaning we have completed a systole and a diastole. And that's why a BP can always be in a fractional form. You have systolic BP or diastolic BP. Now, so meaning when you hear the heart contracts, it will be a diastolic, it will be a systolic pressure. When the heart relaxes, it is a diastolic pressure. When you hear lob, is diastolic. When you hear dub, is systolic. When the heart contracts, there's a there's a systolic BP. When the heart relaxes, there's a diastolic BP. I want to understand this portion. Now, whenever the heart completes one cardiac cycle, definitely there's a wavelength that has traveled from the P wave to the T and back to the P wave. So this lob dub is the same as one full cardiac cycle, or one full PQRST complex have occurred. Now, coming back to this drawing on the board, the heart has various portions. It has two portions, the upper portion and the lower portion. The upper portion is the atria. The lower part is the ventricle. That means this side becomes the right atria and the right ventricle. The other side becomes the left atria and the left ventricle. So when blood travels from this portion of the heart, the rest of the heart, comes back to the left side of the heart and passes through and go into systemic circulation through the aorta, it has completed one cardiac cycle. And this one completion of a cardiac cycle is the same as wavelength passing through the P wave, KRS complex the T wave, it begins over. That's what happened. That is what happened in here exactly. Now, let's understand something here before we can go into this. Whenever you hear the P wave, when you hear P wave, P wave simply means the atria of the heart. The P wave gave us a knowledge, it gave us an idea on what's happening in the heart atria. That means portion of the heart, which is the atria of the heart, is what we call the P wave. So when we hear that the P wave is abnormal, meaning our heart atrium is not working rightly or it's not working properly. So that's why you're going to see atrial flutter, atrial fibrillation or AFib. All of these atrial fibrillation represents the atria of the heart, meaning there's an abnormal P wave occurring with all these atria. When you hear atria, the P wave. When you hear P wave, atria. So any problem with the P wave, it will be an atrial problem. That's one I want us to understand. That's the first thing. Another thing I want us to understand is the QRS complex. Now, the QRS complex represents the ventricle of the heart. So this ventricle here, they are represented by the QRS complex. This is the QRS complex here. It is represented by the heart ventricles. So whenever we hear a ventricular heart problem, we are talking about the QRS complex being abnormal. Whenever there is an abnormality of the QRS complex, there is a ventricular heart problem. That means QRS complex is the heart ventricle. So when you hear ventricular tachycardia or V-tach, there is a problem with the QRS complex. Every V-tach, there will be an abnormal QRS appearance. Now, the last portion of these three segments is the T wave. Now, the T wave under here, the T wave is the same as what we call ventricular repolarization. Ventricular repolarization. It is a big word, but it simply means to restart. So whenever the wave or the current passes through the P wave, the QRS complex, when it reaches at this point, meaning the heart is about to reinitiate a new cardiac cycle. So when you hear lub-dub, before you hear another lub-dub, that resting period when your heart beat boom, boom, lub-dub, lub-dub. When you hear one lub-dub, that resting period, it is the T wave that is being activated at that point. The T wave being activated means the heart is trying to get repolarized to initiate a new cardiac cycle. So the T wave under here represents ventricular repolarization. Simply means the ventricle are about to reinitiate a new cardiac cycle. Now, that is what I want to explain first. Now, I want us to now understand when or how can we identify an abnormal P wave, how can we identify an abnormal QRS complex, and what can we do when we have these problems. Now, because in the NCLEX, they will give us various scripts, various EKG scripts, and these scripts, they will ask, oh, what's the problem with the patient? Is it a ventricular problem? Is it PVC? Is it an atrial flutter? Now, we'll look at the EKG strip in the NCLEX and we'll have to determine what is the problem the patient is faced with. Now, to answer our questions, in the NCLEX, we want to understand how can we identify a normal P wave or an abnormal P wave. How can we identify a normal T wave or an abnormal T wave, or how can we identify an abnormal QRS or a normal QRS or QRS complex? Now, stay with me. Don't go anywhere. I'm going to start with the P wave. P wave. I will start with the P wave. What is a normal P wave? A normal P wave represents certain amount of boxes. Let's go back to another drawing. Now, in the NCLEX or on the EKG pattern, there are boxes you're going to see along the way. These boxes contain smaller and larger boxes. So the smaller boxes, they are 5 horizontal and they are 5 vertically. Now, so this is how they're going to appear. Each one of these small boxes is equal to 0.04 seconds. So one small box is equal to 0.04 seconds, and a big box is equal to 0.20. How? What is 20? If we multiply 0.04 by 5, it will give us 2, it will give us 0.02. If we multiply 0.04 times 5 boxes, it should give us 0.20. So that's how we got this 0.20. So every big box in the EKG rhythm equal to 0.20 seconds, and every small box is equal to 0.04 seconds. For the P wave to be a normal P wave, the P wave should be between half box to 2.5 boxes. This simply means this represents 0.5 to 2.5 small boxes. So every P wave to be normal, for a P wave to be normal, it must be within the range of half box to 2.5 boxes. If it is above 2.5 boxes, it is an abnormal P wave. If it is below half box, it is an abnormal P wave. So every P wave to be normal should fall between half to 2.5 boxes. Let's take for example. Let's say this is the EKG strip right here. So if we have a P wave coming from here like this, now in this section here, this portion here coming here, it is a P wave, because this is the P wave, is the first inversion of the wave. That's the P wave. Now this P wave should be half box to 2.5 box. So we look at it and see whether it is normal or abnormal. It is normal because from here is 1 box, from here is half box. So this is 1.5 box covering the P wave. So this P wave is a normal P wave. If it were below half box or above 2.5 boxes, it would have been an abnormal P wave. I'll give you another example here. Let's take for example 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so here, let's see what we'll have an abnormal P wave here. So if we have a P wave here that starts from here and covers here, come down here, goes back up and come down here and goes this way. Now this becomes an abnormal P wave. Let's say 1. Okay, let's do it this way. It came from here, so meaning this P wave is abnormal because it covers 1, 2, 3. So it covers 3 boxes here, 3 small boxes. So because it covers 3 small boxes, it is regarded as an abnormal P wave, because we said a normal P wave should cover half to 2.5, but in this situation it covers 3 boxes. Definitely it is an abnormal P wave. So that's how we look at the P wave and determine whether it is normal P wave or it is an abnormal P wave. So in this situation, it is an abnormal P wave because it covers more than 3 boxes. Now, then we look at the QRS complex. Let's look at the QRS complex. In the QRS complex also has some value. And in this section, we have to begin with the value. The value are represented by the boxes that each one of these complex or these waves going to cover. Now, for the QRS complex, a normal QRS complex or wave. Now, a QRS wave or KRS complex represents 0.08 to 10 seconds. This is a normal KRS complex boxes. It should be able to cover. That means if it covers more than 10 seconds, it is abnormal. If it is lower than 0.08 seconds, it is abnormal. Now, so in a sense, 0.08 seconds will be equal to 2 small boxes. And 10 seconds or 10 seconds will be equal to 2.5 small boxes. That's 2.5 small boxes. Now, this means when we have it like this, we will count the amount of boxes beginning from here to here. If the boxes covering from here to here is between 0.08 to 10 seconds, they are normal. If they are above that, they are definitely abnormal. That's what it means right there. So definitely, we said that in the case of these small boxes, for the KRS complex, it falls between 2 to 2.5 boxes. Now, in some condition, some material will tell you that it ranges from 10 to 12 seconds. Some book will tell you this, but I stick with the one that talks about 0.08 to 10 seconds. That's the normal KRS complex. Now, so in a KRS complex, so there will be boxes. Let's have another example here. We have a big box in this section. We have it in this minor. Then let's draw a QRS complex in here and see whether it is normal or abnormal. So it begins right here. It comes like this. It comes here. Come up here, down here. Now, this means we have to count from here to here. So we got to count the amount of boxes. This is Q here, this is R here, this is X here. Let's count the amount of boxes covering the QRS complex. So from here is 1 box. Here is 2 boxes. Now, so here it covers 2 boxes. So definitely this is a normal QRS complex because it covers 2 boxes. And we said for a QRS complex to be normal, it must cover at least 2 boxes, up to 2.5 boxes. So that means we understand that this QRS complex is normal because it covers 2 boxes. Now, and whenever we have a QRS complex abnormality, our first choice of answer will start with ventricular because we said the QRS is a ventricular problem. That's what it means in the simple term. Now, then we move to the T wave. So the T wave is called, this T wave is called ventricular repolarization. Ventricular repolarization. Now, that simply means the atria of the heart has contracted, the ventricles have relaxed, they have completed 1 cycle. The resting stage to pick up and complete another cycle is the T wave. So in a sense, the T wave is concurrent to the QRS complex, meaning it's the same as the QRS complex. When the QRS complex is affected, the T wave also is affected. So they have the same numerical value in terms of numbers of boxes they should cover. So if they cover more than 10 seconds, it is an abnormal T wave. If it is below 2 boxes, it is an abnormal T wave. So in short, whenever we are given this problem in the NCLEX, we want to identify whether the P wave is present the QRS complex is present, the T wave is present. If they are present, we want to understand how many boxes, which would tell whether it is normal or abnormal, covering the P wave. How many boxes the QRS complex is covering, which also tell us how normal the QRS complex is, and how many boxes the T wave is covering, which also tells us how normal or how abnormal the T wave is. Because the T wave and the QRS complex, they have similar pattern when it comes to boxes. Before we leave, last thing I want to show you here is we have got the PR interval. The PR interval. PR interval. It is the portion that is found between the P here and the R. This is the R here. This is the R. So between the P and the R is what we call the PR interval. So this is the PR interval. Now, for this PR interval, it's also we have to know the value in terms of boxes of the PR interval in the English. The reason is, if the boxes are not known, we will not know how normal or how abnormal it is. Now, for the PR interval, a normal PR interval is between 0.12 to 0.20. This is a normal PR interval boxes. Now, and under here, when we are speaking of boxes, we are talking about the smaller boxes. Now, 0.12 is equal to 3 small boxes to 5 small boxes. So the PR interval is always between 3 small boxes to 5 small boxes. So definitely, if we check the PR interval, if it is not equal to 3 small, if it is lower than 3 small boxes, it is abnormal. If it is above 5 small boxes, it is also abnormal. So our regular PR interval is between 3 boxes to 5 boxes. Now, I want us to understand this portion. In our next segment, under here will be on how can we, it will be on the various abnormal wave and their treatment. So the next time we meet, we'll discuss about ventricular tachycardia, how do we recognize it, and how can we treat it. If it's a condition, how can we treat heart blocks, and how can we recognize heart block. So watch out for our next video, and we'll give you it. Thank you very much. Have a blessed time. My name is Vasco A. Kone. Bye-bye.